So we're here at the ARM TechCon 2010. So you're an analyst and you specialized in EDA, right?
Right. I'm an old semiconductor guy, design methodologist, and I retired in 1994 and became an analyst. So I write about this stuff and fly around the world and shoot off my mouth, and it's much better than having to tape out or getting a new product out the door.
So EDA is a pretty big business, right?
It's a little over a $4 billion business. It should be much. It should be much bigger than that, and it will be. We're getting into other areas now that will expand the market.
So why should it be bigger?
We need to really look at the software problem as well as the hardware problem, and we've been sort of stuck in the hardware problem mode for the last 15 years. And we just need to expand into other areas, because the big problem right now with design is that most of the design cost now is caused developing the software. So that's one of the reasons I'm at the show, because I'm interested in seeing what ARM is. ARM is the most advanced company today in concurrent software parallel programming with their processors.
Most advanced.
Yes.
It means that the parallel programming that goes on, and for example, the Intel stuff,
Yep.
or the cell processor, and all these other parallel. What other kinds of things are they that are less good, that are less advanced?
Yeah, it's basically because they're in the mobile world and they're living in a multi-core environment. And also a low-power multi-core environment. They've been following this closer than the other microprocessor vendors. Intel's jumping on the wagon now, because they found out that not everything's plugged into the wall, and they've got to get low power, which means multi-core. And ARM's just really been on top of this. I mean, their new A15 processor has some amazing features as far as allowing multi-core processing. And then I was at DATE this year on some panels and at some panels, and people, the engineers were talking about the software tools they were using, and every time somebody asked who has the best tools, the answer was ARM.
So ARM does tools, and the EDA industry does tools. And
Yeah.
how do those tools compare? And is there any risk that ARM does some tools that kind of like compete with what the EDA companies are doing?
No, the EDA guys are just getting there. So ARM has had to put together their own tool set to enable their customers to program their processors.
But how big is the ARM industry? Or how big is the ARM revenue? Or
ARM's revenue? I guess they're about $500 million.
That's it?
Yeah.
And you say EDA is a $4 billion industry.
Yeah.
So how come is that so much bigger than what ARM does, no? I mean...
It's the business models that they're doing.
But still, the EDA is much too small. You say it should be much bigger.
Oh, yeah.
And they complain as well. They want to be bigger, right?
Oh, yeah. Yeah, but they didn't, they think they just need to do the same thing over and over again and get more money for it, and that never works out.
So were you at the fireside chat the first
No,
night?
I missed that. Yeah.
Missed that?
Yeah.
And so they were talking about trying to be complementary or trying to collaborate.
Right.
And,
Yeah, John has been pushing that now for way over 6 months now. So John's caught on. Bergman's figured out what we need to do to grow, and they're doing a pretty good job over Cadence right now, trying to put that together. Mentor has always really understood what was going on, and they've got a pretty good embedded division. So they're in the software business, but the other guys are still pretty hardware oriented.
how come does it cost $125 million to design a processor? Oh, they were talking about that in the key. And what is the cost there?
Most of the cost is the cost of the engineers. That's where most of the money comes from, and that's why the tools are so important, because the automation of the process let you design with less engineers. But right now, you're having very large design teams, especially in the software area. I mean, I've seen 400 software engineers on a project, and that's, the salaries really add up.
So just salaries for a chip from beginning to the delivery is 125 million sometimes, or more or less or something.
For these processors, yeah. For the processors, it costs a lot. I mean, Intel spends an amazing amount of money getting their microprocessors out.
So they actually pay more than anybody else, but they also make much more money.
Yeah.
Somehow, because they control the whole thing.
Well, right, they control the PC world. They're newbies right now in the mobile world.
So how is it at all possible for 400 people to collaborate somehow on something?
Very, very difficult. If you look at a design team, as a methodologist, we were just talking about this morning, 25 engineers is the most you can have on a team before your productivity starts going down. So basically, you have to chop up your design into pieces that you can only use, 25 or less engineers, and then you have to glue the pieces all together. So
it's impossible to be collaborating more than 25 people at a time, and
pretty much.
That's just an algorithm that defines that?
It's just experience.
Experience.
After 25, you plot your curve, and it really you start losing productivity.
And that's across all kinds of software development?
Hardware and software.
So it means that when Google gets 20,000 engineers, it means that they have to have 20,000 divided by 25 different projects.
Pretty much.
And when Apple has 35,000 and when Microsoft has 100,000 or something like that, it's like there's no way they can all work on Windows or something.
Nope.
All right.
Nope.
So they have to work on 80,000 different
on a piece of it,
games.
And then they sew it back together again and hope it works.
All right. Do you think it's going to succeed the way that they will somehow find some way to collaborate, or is that basically incompatible with capitalism?
I think they'll succeed. I think it's the automation is really just going to be the key is automation. You've got to take the boring work and automate it somehow, and that's the job of EDA. That's what they do.
How about when Google and some other people try to do these, where people who don't know how to program, for example, get this kind of like they put some bricks and try to output code?
Yep.
Is that related in any ways to the automation that goes on at a very high level for the
Sure.
people working?
In fact, one of the most popular tools for architectural design is MathWorks tools, and that's what they do. They do block-based design. So it's model-based, what they call model-based design. And they allow people to put together the blocks and see if they work. Now, once you do that, then that has to be refined and optimized because we have a huge power problem right now. So we can't afford suboptimal circuits. So the way you start it is with these blocks, and then you take it down and you split the block up into teams of 25, and they are responsible for optimizing the circuit, so we can use less power to run these things.
All right. So is it like a fascinating industry?
Oh yeah.
Even more than last year and the year before, and it just gets better and better?
It's really exciting now because so much is going on. It was I was sort of boring during the 90s. I called it the cream puff era because everything was incremental. There were no big problems, and then when we hit 130 nanometer, all of a sudden we started hitting the problems, and it's just been accelerating since then. And we hit 130, I think, in 98 or maybe 99. So this decade has been really exciting because of all the problems, and it's been frustrating because for me and for the design engineers, because the problems just aren't getting solved fast enough right now. And that's why the cost of design is so out of sight. We should be able to design things for a minimum of $50 million and hopefully at $25 million.
It should be possible to design a whole chip.
Yeah.
So, I mean, for example, the ARM Cortex A15.
Yeah.
I mean, the thing is, like, you can not go in minus nanometers. At some point, there's like it's too small, right? And
They keep seeing that, yeah.
so this is like it gets more and more expensive to make the chips, and the devices are cheaper and cheaper, right?
Yeah,
You get a $100 Android phone,
yeah.
or
Yeah,
even cheaper.
and that's
than
why we haven't been, the EDA industry hasn't been able to get the tools out to solve the problems fast enough to keep the cost down. That's the issue.
So do you think that it's political in any way to find a solution, or is it
Sure,
just business?
No, it's we're going through an inflection point, and it's the innovator's dilemma, right? All of a sudden, you have to kill your some part of your business to reinvent the way you do things. I mean, Intel's famous. You got to eat your babies. That's what you have to do, and these companies that have been making money on in this case RT level tools for the last 15 years, fairly easily. All of a sudden, people are saying that's commodity stuff. We're not going to pay that much money for it anymore. And so now they've figured out they've got to make a move up to a higher methodology. Well, they should have done that 10 years ago. By not doing that 10 years ago, the cost of design has gone from $25 million to, well, right now it's around $100 million.
All right. So hopefully they'll find a solution.
They'll find a solution. We always do. Yep.
We will find a solution.
Yep. If
Right.
they don't do it, somebody else is going to find it.
They won't just collapse somehow, or.
But it's you lose companies in these transitions, and one of the things we're seeing here is at the show is that the tool set that's being open source tool set that ARM is supporting will decrease the possible TAM for these companies, because all of a sudden they didn't come out with the tools, so ARM and TI and ST Micro and I think it was Freescale's the other one has put together open source group to develop these tools and then give them out free. So all of a sudden you see a bunch of revenue being thrown away.
Right. But sorry, you can answer the phone while we film if you want. Okay. Right. But basically, it's like a disruption.
Oh yeah,
going
major
constantly.
disruption. Yeah.
And so when you give out something for free, it's kind of like it could disrupt some people who used to sell that, right?
Yeah.
And that's a really hard thing to balance out when it's basically just companies.
That's right.
And it's everybody wants to make as much money as possible still.
Yeah.
Okay.
That's the general idea.
Right. Okay. Thanks.
Okay.